All right, in section 12.3, we're trying to get the regression equation, which really means we're trying to find A and B. So if we have, this is our regression equation for straight line. We're trying to get a number for A, and we're trying to get a number for B. Okay, so if this is our table right here, and we'll plot all of these points, so 17 and 94, we'll plot all these points over here, and then draw this straight line. To get the equation for this straight line, that is linear regression. So the equation for this straight line would be 3.1792x plus 30.104. And then we'll talk about this here in a little bit. Okay, we've got three types of correlations. If the line goes up, you have a positive correlation. Line goes down, negative correlation. And if it looks like you dropped all your marbles, you have zero correlation. Okay. It's also the same thing as saying correlation is the same thing as relationship. So a positive relationship, a negative relationship, or no relationship between your x and your y variables here. Okay. Now something called the residual. So all your data points will have an xy coordinate system here. So your residual is actually the distance from this is your actual data point to the line. So this right here is the actual data point. That's what all these little purple bluish dots are. These are your actual data points. Everything on the line, this little yellow point right here, this is an estimate for this point right here. Now the distance between these 2 points, that's what you call the residual. Okay, so we call this data point right here y sub 0. And we call this data point right here y hat sub 0. This data point right here, anytime you've got a value on the line, it's going to have a little bit of error to it most of the time. So since it's got a little bit of error to it, it has to wear a hat because it's ashamed of its error. Okay, that's how I remember it. So y hat sub 0, this is all the points on the line. Y sub 0, those are your actual data points. The distance between these two, that's what you call the residual. Okay, and you can also call it a residual or an error, but I stick with residual on the test. Okay, so like I said, all the points on this line right here, most of the time, they are an estimate to your true data points. Okay. Now, if your observed data point lies above the line, okay, so for this one, oops. All right, so this point, we'll actually take this point right here. It lies above the line. Okay, so the residual is positive, and the line will underestimate the actual data value for y. Because what you're going to be seeing, based on the equation that we're going to get, is this number right here on the line. This is the number used to estimate your actual data point. So since it's lower than your actual data point, it will underestimate the actual data point. Okay, if you look at a data value below the line, okay, on our equation, this is the point on the line that we will see. And notice how it is above the actual data value, so it's going to overestimate, like it says here. If the observed data value lies below the line, the residual will be negative, and the line overestimates the actual data value for y. Okay. So most of the time you're not going to have your data fit a straight line exactly. Okay. So we're going to have to deal with rough predictions. So most of the time your scatter plot is going to appear to fit a straight line. Not all the actual data points will be on that line. So finding this line, that is the line of best fit or least squares line. And it has the equation y hat is equal to a plus bx. Okay, where a is equal to y bar minus b times x bar. Y bar and x bar are the sample means for the y values and the x values respectively. We already said that y hat is an estimate for y. This y right here is all the numbers on the line. This y right here is your actual data values. Okay, and you've got two formulas for b. I'll show you which one we're going to actually use here in a minute. But if you use this one, this is going to be your S sub y and your S sub x. These are the standard deviations for your y values and your x values respectively. And R is something called a correlation coefficient. Okay, and here would be your formulas for S sub y and S sub x. Okay, the process of fitting the best line, finding the absolute best line for your scatter plot, that is called linear regression. Okay, so what we want, this is the key here. We want all the residuals to be made as small as possible, or all our data values to be as close to that line as we can get it. Okay, this linear coefficient R has this equation right here. And what it does, so your correlation coefficient R, it's a number, and what that number will tell us is it measures the strength and the direction of a linear association between the independent variable x and the dependent variable y. It'll basically tell us how strong is this relationship between x and y, and if it's a negative relationship or if it's a positive relationship. Okay, so like I just said, your correlation coefficient R will show you the strength of the relationship between your two variables, x and y. R will always go between -1 and 1. So you could write like this. From -1 up until 1, that's all the possible values that R could be. Okay, so values of R close to 1 or close to -1, that means you're going to have a strong linear relationship between x and y. So the closer you get this direction or this direction, that's the stronger the relationship will get. Over here, this would be a stronger positive relationship. Whereas over here, this would be a stronger negative relationship. Okay. So if R is equal to 0, that means there is no linear relationship between x and y, or you can say no linear correlation. So if R is equal to exactly 1, this is a perfect positive correlation. So that would look like, if these are my scatter plots right here, then every single point would fall on that line. This is R equal to 1. And because it's positive, positive 1, positive correlation. If R is equal to -1, that's a perfect negative correlation. Okay, so if we had our scatter plot They're going down, and then every single point falls on that line. Okay. If every single point falls on that line, then that means that r is equal to -1. Okay. But most of the time, this is not going to happen. Okay. So a positive value of r means that when x increases, y will increase. And when x decreases, y will decrease. That's a positive correlation. It's like if you look at this point right here. Here's your x variable, here's your y variable. This is high value for x, high value for y. At this point right here, here's your x variable, here's your y variable. Low value for x, low value for y. Okay, if it's a negative value for r, that means that when x increases, y will do the opposite. It will decrease. So if we look at this point right here, okay, I have a high value for y, but a low value for x. If I look at this point right here, I have a high value for x, but a low value for y.